Hello everyone. In this video, today we are going to see what is called empirical rule or 3 sigma rule, or sometimes it is called as 68, 95, 99.7 rule. So we are going to see what it says, how to apply it for our sums, etc. Okay. So now, whenever we have a normal curve, so it will be written like this. Okay, so for example, will be written like this, mu and sigma. So what is this mu? Mu is nothing but mean, okay, and mean, right? This is standard deviation. So according to that only, we are going to construct this particular normal distribution curve. See, for example, my mean is 50 and standard deviation is 10. How I am going to construct this is, so I'll write here 50 for this mu. Now, from here to here, we'll be having one standard deviation difference that it says plus. So what I'm going to do is, I'm going to have 50 plus my standard deviation is 10. So this will be written as 60. Similarly, this will be written as 70. This will be written as 80. When you come from the left hand side, see it is 50 minus one standard deviation, then it is 10. So I'll be writing this as 40. Okay. So normally this will be 30, this will be 20. So what is the meaning of the mean plus or minus one standard deviation? What is the meaning? So now, mean plus or minus one standard deviation. What is the meaning is, actually, what is my mean? Mean is 50 minus one standard deviation is 10 to mean is 50 plus one standard deviation is 10. So what is my value is 40 to 60. I will say 40 to 60 is the area covered between mean and one standard deviation. So what does this empirical rule says? Actually, 68% of your value will lie in between 40 and 60. That's the meaning for this. Then actually 95% of values will lie between 30 and 70, and 99.7% of your values will lie between 20 and 80. This is the meaning of the empirical rule. We are going to have one example to see this. Okay. So now imagine that these are all the marks obtained by our students actually. So it starts from 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm going to have this as the mean value for them. Then my mean value mu is equal to 50. Then my standard deviation, I'll got it as 10. So I want to construct a normal distribution. Usually when you mark the marks itself, it will construct your normal distribution here. How to construct this? Actually, see, one student got 10 marks, for example. I am marking it here. Okay, so one student got 10 marks. Similarly, another student got, two students got 20 marks, and one around two students, okay, got 15 marks, for example. So I'm going to just mark it down here. So when you mark down all these values here, what we are going to have, we'll be having like this. We are going to have a distribution like this. So when I want to draw a diagram, so it is normally distributed. What is the meaning of normally distributed is the mean and median and mode are equal for this. Okay, so now it is symmetrical. Both sides it is equal. When I draw a curve like this, I'm going to draw a curve like this. So this shows me the normal distribution for me. So now this is an example we are going to explain for the empirical rule. We are taking the same example. Now the marks ranges from 10 to 90, for example. Okay, so now how to just see how many students scored like this. Okay, now how many students scored the marks from 40 to 60? That is, what is this? Okay, so starting from here and start up to here, how many students? Okay, this is the area I'm going to cover it here. Okay, I'm going to find it out. Now 40 to 60, how many students have scored the marks? That is mu plus 1 standard deviation. Then from 30 to 70, how many people scored? That is, this is mu plus or minus 1 standard deviation, that is sigma. Here, when I have this from here to here, if I have, that is called mu plus 2 standard deviation. Then the last one is mu plus 3 standard deviation. So mu plus 3 standard deviation implies that our student got the marks from 10 to 90. How many students got the marks? It is 99.7% of the students got the marks, ranges from 10 to 90. That's what. So I'm going to show it diagrammatically, the same example here. Right. This is what is the curve. We'll call it as mean 50 and standard deviation 10. Okay. Yeah. So now imagine that we are having the same example here. We are going to have the value of 50. I'm not mistaken here. I think we have taken 50. Yeah, 50 here. Okay, 50 will be the mean for us. Okay, now 1 standard deviation comes plus 10. So 50 plus 10 will give you 60. 60 plus 10, 70. 70 plus 10, 80. Then here 50 minus 10, so it is 40. Then it is here 30. See, for example, 30. Then we are going to have this as 20. Okay, so now see, from there only I have taken, see, we have taken the marks from 20 to 80. Okay, so now if it is mu minus 4, see, always imagine, see, this curve will not touch this x-axis here. It will go on like this. Now, if I want to extend it, I can extend it so that my value starts from 10 here, my value ends from 90 here. Okay, so now we have, for demonstration purpose, we have taken from 20, 30, 40, 50, 60, 70, 80, because this is the center. Now, I want to find out how many people scored between 40 to 60. That is mu plus 1 standard deviation. Okay, now 1 plus or minus 1 standard deviation. That means from 50, you have to subtract 10. So we'll get 40. 50, you will add 10, you will get 60. So I want to find out how many students are getting the marks from 40 to 60. That is what is given as 68%. Okay, now how we are going to calculate that? So I'm going to show it here. Okay, now this is it, right? Now we are having two parts here. Okay, now the part number 1 here and part number 2. Here, see, more than 50, how many students will get? In a normal distribution, it is nothing but 34.1% students will get more than 50. Then here, how many will get less than 50? Between more than 40, less than 50, how many students will get? 34.1%. This is what is said. 68% of the values lie between 1 standard deviation, between the mean plus 1 standard deviation. That is what is shown here. Okay, now see, this is 34.1%, 34.1%. We usually take it as 68 only. Okay, now roughly. So now this is what is the 68% of the students will get marks in between 40 to 60 in a normal distribution. So we are going to have next one. What is that? How many students will get marks from 30 to 70? How the 70 has come? See, my mean value is 50. I'm going to write it on the top. You can see now mean value is 50 plus 2 into sigma. See, this is, I'll write it as mu plus 2 sigma. That means plus or minus. Okay, so now mu is 50 minus 2 into 10 is 20. Okay, similarly 20. Similarly 50 plus 20. So it is ranges from this is 30 to 70. Like that only we are going to calculate. Now, which will be the area here? This is the area. So how many percent will come for this blue color area? See, actually it is coming 13.6%. Okay, now from this diagram I can say, see, 60 to 70, 13.6% of people would have got the marks. Here from 30 to 40, 13.6% will have the marks. Now, see, mu plus 2 standard deviation, that means from 30 to 70, how many people will get the marks? It is nothing but 90. See, we are going to show once again, right? Right. So here, 95% will score between 30 to 70. Similarly, the same procedure we are following it for the next one, that is for 3 sigma. So 3 sigma means 3 into 10. See here, mu value is 50. So I'll write it in both the sides. You'll understand now. 50 minus 3 into 10. So it is 50 minus 30. So it is coming 20. So 15 plus 3 standard deviation. So mu plus 3 sigma, right? So 53 into 10. So it will come around 80. So what I'm going to have is, so how many people got from 20 to 80? Okay, so I made a small mistake here. So you can, it's not 70, right? So it should be 80. So 97 here, 99.7 people will get the box from 20 to 80. This is what is your empirical rule says, or the particular rule, we call it as 3 sigma rule, or 68, 95, 99.7 rule. I hope you like this explanation. Just kindly subscribe to my channel. If you have any doubt, just put it in the comment box so that we can clear it. Thank you very much. Have a good day.